Okay, here we have a problem. Analyze the beam shown in figure and draw SFT and BMT. Here is a simply supported beam subjected to point load at a distance of 2 meter from left support. Okay, let's go for a solution. Now we have to write a free body diagram. For each support we have a two reaction, vertical and horizontal. For roller we have only one reaction, vertical reaction. Since there is no horizontal loads, let's neglect horizontal reaction. So let us consider a vertical reactions. So I have taken as VA and VB. Now by using equilibrium equation, for sum of vertical forces is equal to 0. So therefore we can write VA plus VB is equal to 20. That means sum of the forces acting upward should be equal to sum of the forces acting downward. So let us say it as equation number 1. Now let us take another equilibrium equation. Sum of the moment about a point A is equal to 0. That means sum of the forces about a point A, okay, sum of the moment about a point A should be equal to 0. So now let us take moment about a point A due to reaction VB. So VB is acting at a perpendicular distance of 5 meter about a point A. So and it will try to rotate in anti-clockwise, or it will try to bend in anti-clockwise. So I will take it as minus, therefore minus VB into 5. So there is another force 20 kilonewton which is at a perpendicular distance of 2 meter from point A. So which will try to bend in clockwise direction, that is 20 into 2, that is plus 20 into 2, so is equal to 0. You may have a doubt why I have not considered VA. Okay, there is one more force VA, because it is acting at the same point. Okay, if it is acting at the same point, it will not create any rotational effect. Or else you can remember in another way, moment can be calculated with force into perpendicular distance. If it is acting at the same point, we will not have any perpendicular distance. So VA will not cause any moment about a point A. So by solving this equation, we will get VB value. Now by substituting the VB value in equation 1, we will get VA value. Okay, so we got VA and VB. VA is 12 kilonewton and VB is 8 kilonewton. So let us go for a shear force values. So initially shear force is 0. At A, 12 kilonewton is acting upward, means shear force at A is pushing upward, means upward you have to take positive. Okay, so 12 kilonewton, right? So up to C there is no forces, that means shear force will remain constant up to C. So that is 12 kilonewton only. When it comes to C, there is a force 20 kilonewton acting downwards. So previously shear force was 12, so now there is a 20 kilonewton acting downward, that means 12 minus 20, it will push downward by minus 8 kilonewton. Again up to B there is no forces, C to B there is no forces, that means whatever the shear force value will be there at C, it will remain same up to point B, that means it is minus 8 kilonewton only. When it comes to point B, there is a reaction VB which is pushing upward, so minus 8 plus 8 will become a 0 kilonewton. So this is how we can calculate shear force values. Okay, now similarly let us calculate a bending moment values also. So since end supports are simply supported, moment at those points will be 0. Okay, because it will not restrict the rotation. Okay, remember if end supports are simply supported, roller or hinge, always moment is 0 at those points. So now here end supports are A and B, so moment at A and B is 0. Okay, directly I can write. So now I need to recalculate moment about point C. So now if I calculating from left side, there is only one force VA, perpendicular distance is 2 meter, so 12 into 2, 24 kilonewton meter. It is creating a clockwise moment, so I will take a positive. So sign conventions I have discussed in previous video. Okay, so we have got shear force values and bending moment values. Okay, now let's draw shear force diagram. First draw a baseline, okay, and represent the points A, B and C. Now shear force is initially 0. From 0, VA is pushing upward by 12 kilonewton. Okay, you just draw 12 kilonewton upward. Okay, from A to C there was no load, there is no load, so it will remain same. Okay, 12 kilonewton only. At C, 20 is pushing downward, 12 minus 20, it will become minus 8. Okay, again from C to B there is no loads, so it will remain same up to point B. So again at point B there is a 8 kilonewton pushing upward, so it will become 0. So it will start from 0 and it will end with 0. And one more thing you need to remember is above the baseline is positive, below the baseline is negative. And very important thing is wherever shear force changes its sign, there you will get maximum bending moment. That means here is shear force changing its sign at point C, there only you will get maximum bending moment. Okay, let us draw a bending moment diagram. So first draw a baseline by representing the points A, B and C. Okay, so here we already calculated the bending moment values. At A it is 0, B is also 0, at C it is 24 kilonewton meter. Okay, so now just join the lines ACB, okay, linearly, because bending moment will vary linearly. That finishes bending moment diagram. Okay, that's all.